Okay, listen to the next 12th standard elementary transformation of the matrix. What is this transformation of matrix? That is interchanging the rows and columns. So rows by another rows interchanging, and then column by another column. Like that, you can interchange the rows to column, ith row to jth rows, or ith column to jth column. Similarly, a row I you are multiplying by your row I changing to row j by multiplying k times. Similarly, column ith column you can change it to jth column by multiplying one more constants. Similarly, you can add that rows and columns. See, r1 you can interchange as r1, that is ri plus k times rj. You can interchange that, transform that row 1, that row I to row j by adding and multiplying some constants. Similarly, columns also, ith row you can interchange as ith row plus ith column plus jth columns by adding a jth column with another multiplying constants. So you can interchange the given rows and columns by adding and multiplying. It's one more rows and columns, and you can find the rank of the matrix to simplify the terms. Now, in order to find the equivalent form, what is it equivalent form? And matrix of order m by n is said to be equivalent form if a row has all its entries 0 will lie below the row having non-empty 0, that non-zero entries. Suppose if you have like this 1 2 3 0 0 0 2 1 3, like this form is called the equivalent form. That means all the entries of the rows are 0. See, first row, the second rows and third rows, the entry is zeros, and one row that has all the elements. A matrix of order m by n, this is order 3 by 3, is said to be in equivalent form if the row having all the entries as 0. See, or if the row starting entry is 0, here also 0 zeros, will lie below the row having the non-zero entries. One of the rows should have all the entries, the remaining rows and columns can have the zeros. Means this form of matrix is called the equivalent form of matrix. So you are going to change the matrix to the in the equivalent form and do the rank of the matrix. So all the matrix you change it to the rows and columns. If you make it as zeros, means then you can easily find the rank, is it not? Change the rank 3 by 3 to 2 by 2 matrix. You can find the rank easily. So that is finding out determinant of the matrix is very simple using this equivalent form. So once if you make all the rows, that one of 2 rows and columns to be 0, means that is in the triangle form. See, you can make the triangle form of that element is 0, means that form is called the equivalent form. Then you can easily find the rank of the matrix. This form is called the equivalent form. Okay, this is used to find the rank of the matrix. This can be obtained by the elementary transformation of the matrix. You can transform the row I to row j by multiplying or adding one more row and columns, right?